Next, we move to the measures of the binomial distribution. So when we say the measures, here we're talking about the mean, the variance, and the standard deviation. So we did new formulas for all these back in the first half of this chapter. And it turns out there are even simpler formulas when it comes to the binomial distribution. So let's take a look. The mean, if you're talking about a binomial distribution, the mean, we use the mu there. Mu equals n times p. It's as simple as taking the number of trials multiplied by the probability of success, n times p. Just really nice. Just multiply two numbers. The variance and the standard deviation are as follows. So the variance, sigma squared, is n times p times q. And once you have the variance, to get the standard deviation, again, simply take the square root. Sigma equals square root n times p times q. Now, I'm not going to prove these formulas. If you want to look further into that, then you're certainly welcome to, or talk to me in office hours or so. Okay, let's jump into practice number 7. The statistical bulletin published by Metropolitan Life Insurance Company reported that 2% of all American births result in twins. Consider a random sample of 8,000 births. For one, do you guys recognize the Metropolitan Life Insurance Company? Usually they go by MetLife. You see their commercials, or sometimes you'll see a blimp, and their mascot is, I don't know if it's mascot, their guy is Snoopy, MetLife. Okay, anyway. So 2% of all American births result in twins. And we've got a random sample of 8,000 births. So in part A, find the expected number of births from those 8,000 that would result in twins. Okay, so you may remember the expected number, well, that's the same as the mean, the average. Okay, so we'll get right into this. To find the mean, we need n and p. Well, what is n? N's going to be the number of trials, right? And again, it's we pull this back to births. So there's 8,000 trials, 8,000 births. Okay. What are we going to deem a success in order to get a number for p? You think, well, what seems natural here is just to say that the birth resulted in twins. So p is 0.02, 2% chance that twins resulted from this birth. A success is twins. Okay, so what does that make q, the probability of failure? Well, it's got to be 0.98. There were not twins born, right? Would be a failure here, 0.98. And okay, now we're ready to calculate these. So in part A, the expected number, we'll call it capital E, but it's the same formula as the mean. N times P, 8,000 times 0.02, which works out to be 160. And if you're wondering, all right, well, what would 160 what? What does that represent? Well, it'd be 160 births resulting in twins. It's almost tempting to say it's 160 twins, but that wouldn't be true. It's 160 births that result in twins. So there'd actually be 2 times as many twins born. Okay, but yeah, 160 out of that 8,000. Now this really makes sense, right? There were 8,000 births, 2% chance of getting twins. We'll take 8,000 and multiply it by 2%. 8,000 times 0.02. That's 2% of 8,000, right? That's how many you would expect if it's really a 2% chance of having twins. All right, so that formula makes some sense. Part B, find the variance. All right, no problem. Sigma squared equals n times p times q. So 8,000 times 0.02 times 0.98. And that works out to be 156.8. Okay, that's measuring the spread of the data. Very spread here. That's a big spread. because the chances of having twins are small. For each sample, there's going to be a lot of deviation. Is kind of what's okay. That's probably looking too deep. Part C, find the standard deviation. All right, take that number, take a square root. Square root of 156.8. If you round to one decimal place, it's 12.5. Okay, very nice, very nice. So remember these formulas. Right now, we've got like 3 different ways to find mean, variance, and standard deviation. 2 different ways in this chapter. So if you're looking at a binomial, right, use these even simpler formulas. Let's move on. Actually, let's stop here, and we'll get to the Poisson distribution next.